Welcome back. In the last session we have seen the summary, right? Let me erase. I hope this is what is noted down. Okay, now the final circuit, DC plus AC circuit, DC plus AC analysis. Okay. Now, don't write anything. What is DC circuit? Let us start from DC circuit. DC circuit is nothing but your cell bias circuit. Whatever we had seen in the case of BJT, the same thing is applied. Right? Therefore, here the current entering into gate is equal to 0. We have VThevenin, RThevenin. No need to consider about RThevenin because the current which is what is flowing through VThevenin, RThevenin into gate is equal to 0. Tell me what is the voltage here? The voltage what you are applying at the gate, R2 divided by R1 plus R2 into VDD. That is what is the voltage which is what is applied to the transistor gate. Now with that VGS, right? And we know that the VDS, whatever VDS you are applying, the VDS should be greater than or equal to VGS minus VT. Then only the MOSFET is in saturation. Only when the MOSFET is in saturation, that voltage control current source is valid. Therefore, whatever equivalent circuit we had taken till now, assuming that transistor is in saturation, only when the transistor is in saturation, then only the AC equivalent circuit, whatever we had taken, that is valid. Okay. Therefore, this is in saturation. We are choosing RD, RS, R1, R2 such that the transistor is in saturation. Not only keeping the transistor in a required region, in the case of MOSFET, saturation region, the operating point whatever which is what is set. Therefore, let us say this is what your VDS, this is VDS, right? And this is what your capital ID. Therefore, what is your operating point? The operating point is nothing but capital VDS, comma, capital ID. Okay. This is what your operating point. It should be stable. Therefore, the operating point should be stable. And it is stable due to what? Due to RS. Because that is what is your feedback resistor RS. This is what is providing negative feedback. We know, right? Same. Maybe little bit I can explain. What is ID? In the case of BJT, IC is equal to beta into IB plus 1 plus beta into ICBO, and it is function of temperature. If temperature rises, IC is also changing. our IC is increasing. Therefore, to stabilize that, we added RE. Similarly, what is ID here? If you ask me, ID is equal to, I already gave, right, saturation current equation. Mu n Cox W by 2L into VGS minus VT whole square. VGS minus VT whole square, right? Now, your mu n is function of temperature, mobility of the, therefore, where your mu n is inversely proportional to the temperature T to the power of minus m, and the VT, Cox is process dependent, W process dependent, L process dependent, VGS, that is what is depending on bias voltage, and VT, the threshold voltage, it is also function of temperature. For all together, therefore, the ID, whatever you have, is also what? Function of temperature. If ID is function of temperature, right? If temperature changes, or let us say if temperature is increasing, ID is increasing. When ID is increasing, that depends. For example, here, that depends on threshold voltage. If temperature increases, threshold voltage decreases, and if temperature increases, mobility decreases. Therefore, here when threshold voltage is decreasing, then VGS minus VT is increasing, mu n is decreasing. Out of these two, which is dominating, right? In olden days, that depends on process to process. If VT was dominating, then overall your ID is dependent on VT. Even though mu n is also depending on temperature. Okay. Therefore, if temperature is increasing, overall your ID was increasing. Therefore, olden technology, let's say, therefore, if temperature increases, typically ID increases. Typically. Therefore, more temperature, it is faster. That is with respect to threshold voltage. Because when temperature increases, your VT, maybe instead of writing directly ID, if temperature increases, the VT decreases. The amount of gate to source voltage required to form the channel decreases. Then if VT is decreasing, overall your ID, that is what is increasing. That is what is dominating. Therefore, ID increases. Therefore, tell me, if temperature increases, your ID is increasing. If ID is increasing, the same current is flowing through RS. If same current is flowing through RS, the drop across RS is increasing. When the drop across RS is increasing, voltage at source is increasing. When voltage at source is increasing, the gate to source voltage is decreasing. When the gate to source voltage is decreasing, your ID will decrease. Therefore, whatever change in ID due to temperature, now the same ID is controlled back because of negative feedback. This is exactly same as our self-bias circuit which we had seen in the case of BJT. Okay. Therefore, I am not explaining. Therefore, no need to calculate stability factor also. Even if you calculate stability factor, you will get it, but not required. Okay, that is not required. Now, this is what is compensating the change in ID. Therefore, we need this circuit. We want self-bias circuit to have Q-point stability. Done. What do you need from AC analysis? Therefore, this is the DC circuit. Now, what do you need from AC circuit? Therefore, from AC analysis, we want common source amplifier, because that is what is giving you more voltage gain. Therefore, if you take common source amplifier, this is the load, and this is your V0, this is your Vi. This is what we are expecting from AC analysis, right? Gate, source, drain. This is what we are expecting, right? This is what is your AC circuit. That's fine. Now, let's have the combined circuit. DC plus AC circuit. Now, first of all, DC circuit, Then the DC voltage should not be given to your load. This is what is your actual load, small v naught. This is what is coupling capacitor, and this is what your bypass capacitor. This is a drain, right? CD, but normally you'll confuse. Okay, anything is fine. This is coupling capacitor, and again we got input coupling capacitor. Now this is what is your input AC signal. Let us say Vi. Okay. Now this is gate, drain, source. Therefore, what is the name of the circuit? This is nothing but RC coupled CS amplifier, common source amplifier. Similar to your BJT. It is not direct coupled, right? RC coupled CS amplifier. Therefore, if you see what is your RL, actually your RL, this is not RL, RL dash. RL dash will be equal to your RL in parallel to the RD. That is what you will get here. Okay, that is what you will get. Therefore, now if you see AC analysis, short circuit, this is connected to ground, R1 is coming in parallel to R2, that is what is coming in parallel to your VI. Therefore, in parallel, therefore VI in parallel to your resistor is nothing but what? What is applied? Now, this is short circuit, source is connected to ground, then drain is connected to what? Output RL in parallel to RD, therefore it is coming to common source amplifier configuration. Therefore, this is what is your common source amplifier. This is CS amplifier, and this is self bias circuit. Okay, take it. Therefore, this is what is our MOSFET final circuit, which is RC coupled common source amplifier. Take it. See, I am not investing much time because we had seen why we had come to this configuration, which is self bias configuration, that we had seen already from BJT. I am not going to like again one by one, but already we can take the self bias circuit where it has the negative feedback, and we want common source configuration. If you combine, we are getting RC coupled common source amplifier. Okay. Therefore, with this DC analysis also kind of done. See, whether it is BJT circuit or MOSFET circuit, when I say DC analysis, it will deal with input KVL, output KVL along with device equation. Here the device equation is different. What is device equation? ID is equal to mu n Cox W by 2L into VGS minus VT whole square. But if you take BJT, what is device equation? IC is equal to beta into IB plus 1 plus beta into IC naught. Right? Those equations we need to take like DC and then input KVL, output KVL and then substitute, you will get the answer. But coming back to AC analysis, we don't bother about DC quantities and then biasing circuit. We always bother about the input signal, load, the the configuration. If you know the configuration, let us say common source amplifier, whatever summary table I gave, that is only for AC analysis. Once you know the configuration, apply the formula to get the answers. Okay, fine. Because we are classifying into AC analysis and DC analysis. Okay. Even if you want to know with respect to JFET, just take out MOSFET, put JFET. That's it. You'll get it. But JFET is not required. JFET is removed from the syllabus. Nobody uses JFET in current VLSI. I'll give you one more minute, try to complete in a minute, then I'll explain amplitude distortion. Okay, I explained about frequency distortion and phase distortion. Let me explain amplitude distortion. Okay, then with that I can say the distortions related to any system is covered, are covered. Over. Okay, now types of distortions, then we will see amplitude distortion. And then what is the reason to have amplitude distortion? And what is the solution to get rid of that amplitude distortion? Now, this is generic actually. If you take any system, don't write any system, okay? Any system defined with output and defined with input. Every system is associated with three types of distortions, or the types of distortions what we can get, right? Distortion. What kind of distortion? I'll tell. Therefore, types of distortions. Types of distortions. Okay. Number one, amplitude distortion. Amplitude distortion. Number two, frequency distortion. Frequency distortion. Phase distortion. Right? Yesterday I discussed, or last class we discussed the frequency distortion and phase distortion. Right? What do you mean by frequency distortion? If gain is not constant, then that is what is called, with respect to frequency, that is called frequency distortion. If phase response of the system is not linear with respect to the frequency of input signal, then that is called phase distortion. I already told, right? The system which is not having gain, which is flat, that is what is having frequency distortion. And the system which is not having linear phase response with respect to frequency of input signals, that is what is said to be having phase distortion. Then what about amplitude distortion? That's why practically definitely will have frequency distortion as well as phase distortion. No system will have bandwidth infinity. Every system is defined with some bandwidth, right? If every system is defined with some bandwidth, practically in what range of frequencies you have, you don't have frequency distortion or phase distortion, that is what is the range of frequencies in which gain is constant or phase is linear. That is what is nothing but 3 dB bandwidth or absolute bandwidth, whatever it may be. Therefore, now what is amplitude distortion? Then amplitude distortion is related to what? Amplitude distortion is related to system linearity. system linearity. Okay, take this, then I'll explain what is amplitude distortion. Okay, and these two are related to frequency response analysis. These are all related to frequency response analysis. And this is what is related to amplitude distortion, right? This is related to linearity. Okay, take it. Then I will speak about amplitude distortion. Over? Now, just listen. Now, let me speak about amplitude distortion. Now, let me take case 1, linear system or linear amplifier. Example, linear amplifier and a non-linear amplifier. What do you mean by linear amplifier? Don't write anything. Therefore, what is the equation which is supporting linearity between input and output? Can I say V0 is equal to A into Vi? Maybe for your understanding, let me take A is equal to 100, right? Therefore, if you ask me to plot, or this is what is, therefore, when I say this is what is the system where it is having, this is nothing but linear system or linear amplifier, then this is what your V0 and this is what your Vi, having the gain, that is what is your A, right? Let us take A is equal to 100 and V0 is equal to 100 into Vi. Then if I plot, just listen here, this is your Vi and this is your V0. Then what is the relation between, because V0 is equal to A into Vi, this is nothing but linear equation, right? Therefore Y is equal to mx. This is what it is. Remember, let us take your V0 is in volt scale and your Vi, let us say this is in millivolt scale. Okay. Now let us say this is what is my maximum input what you can give, and this is what is the minimum input what you can give. Then corresponding to input, then this is what your minimum output, and let us say this is what your maximum output. Okay. Let us define operating point. When input is defined with some bias voltage, then your output is also defined with some bias voltage. Okay. This is what people call it as operating point, right? Q. This is what your operating point Q. Therefore, now if you ask me, right, and this is what is the input DC voltage, let us say input bias voltage. Now let me apply the signal whatever I want to amplify. Now when I apply the signal whatever I want to amplify, let us say your input is swinging from minimum to maximum. When input is swinging from minimum to maximum, and this is nothing but your time axis, this is nothing but your time axis, what it may be, okay, this is your time. Then what is your output, corresponding output? Your output is also changing from minimum to maximum. Okay. Now for your understanding, let me take the peak to peak, right? If you take peak to peak 100 millivolt, if you take peak to peak, input peak to peak 100 millivolt, And what is your output peak to peak? Your output peak to peak will be 100 milli into 100. In our example, what is a 100? Therefore, 100 milli into 100, you will get 10 volt peak to peak. Therefore, this is what it is. Therefore, this is nothing but when you give a sine wave at the input, we are getting a sine wave at the output, but output peak to peak divided by input peak to peak is nothing but your voltage gain. Therefore, because your amplifier is linear, V0 is equal to A into Vi, whatever signal you apply, therefore A into Vi you are getting at the output. Therefore, now this system is said to be not having any amplitude distortion. There is no amplitude distortion. No amplitude distortion. No amplitude distortion. But if you consider non-linear amplifier, that is what I am saying, case 2, okay, this is your Vi in millivolt, okay. If you consider case 2 non-linear amplifier, therefore, what is the equation which is supporting it? Okay, let us say V0 is equal to A into Vi plus some D into Vi square. Actually, C into VIQ plus D into Vi to the power of 4, etc. That is completely higher order non-linear equation. Let me take only second order, that is what is enough. Then tell me, this is what is your system, but this is non-linear. Non-linear amplifier. Then this is nothing but your V0 and this is what your Vi, right? Then let's see. Therefore, if I draw, this is your Vi and this is what your V0. Again, this is volt scale, this is millivolt scale. Okay. Now tell me what is the relation between Vi to V0. It is like Y is equal to Ax plus Bx square. What is Y is equal to Ax plus Bx square? It is a parabola. Here Y is equal to Mx, it is a straight line, but here Y is equal to Ax plus Bx square. Then it is a parabola that depends on the value of B. If B is positive, then it will be this kind of parabola. If B is negative, you will get this kind of parabola. I think let me take B negative or what it may be, this is what is your parabola. Therefore, you will get, this is your parabola, non-linear equation. Now let us say this is what is defined with maximum input and this is defined with minimum input. Then corresponding, this is what your minimum output and corresponding this is what is our maximum output. Okay. Now let us say this is what is your operating point. Then this is what your operating point. Then again let us give the signal whatever you want to amplify. The signal whatever you want to amplify, let us say this is nothing but same 100 millivolt peak to peak. Then what you get? Let us say Y0 is equal to A is 100 only, but B is some value. Therefore, A into 100 minus B into something. Overall, if you see what you get, you will get almost same 10 volt peak to peak. Therefore, this is almost close to 10 volt peak to peak, but less than 10 volt peak to peak. But you can say almost close to 10 volt. But you see here, your output peak to peak divided by input peak to peak, that is what is your voltage gain. I agree. But if you see here, the input is sine wave. But is it sine wave? Looks like your average value is shifted. No. Average value is not shifted. The sine wave which has different positive swing and then different negative swing. Can you call that as sine wave? No. When I say sine wave or cos wave, positive half cycle magnitude is equal to negative half cycle magnitude. But here positive cycle magnitude is different and the negative half cycle magnitude is different. Therefore, this is what is called amplitude distortion. Your amplitude is distorted. Even though you are getting gain, output peak to peak divided by input peak to peak, that is what is giving you gain. But your amplitude is distortion. Therefore, this is what is called, the system is said to be having amplitude distortion. Amplitude distortion. Or people call this as harmonic distortion. This is also called as harmonic distortion. This is also called as harmonic distortion. Okay. That is because of non-linearity. Mathematically also I can explain. If you say Vi is equal to, I don't have space, but for example, if you take, let us say, let Vi is equal to sin omega t, right? Then what is your output? If the system is linear, then what is your output? Your output will be equal to A sin omega t. That is fine, right? Now, here, let us say your Vi is equal to sin omega t. Then if system is non-linear, then what is your output? Your V0 is equal to some A into sin omega t plus B into sin square omega t. What is sin square theta? Can I write it like 1 plus cos 2 theta or 1 minus cos 2 theta by 2? Let us say, therefore you will get second harmonic, what it may be. Therefore you will get sin omega t and sin 2 omega t. Therefore this is what is called second harmonic. This is fundamental frequency, which is nothing but your input signal frequency. Therefore this is what is second harmonic of your input signal frequency is also coming into picture. If you add those two, whatever signal you get, that is what you are getting. That's why this is called harmonic distortion. Because of its harmonic, we are seeing distortion. If you consider third order, you will get sin 3 omega t. Fourth order, sin 4 omega t. If you add all those frequency components, whatever signal you get, that is what is your output signal, which is what is having harmonic distortion. Right? Therefore, tell me, we should not have any amplitude distortion. What is the meaning of it? Let us say loudspeaker. I am speaking here. I am giving some input signal frequency, but loudspeaker is producing different frequencies. Means different frequencies means along with the fundamental frequencies whatever having, whatever input is having, its harmonics are also coming at the output and then giving you out, adding to the fundamental frequency components and then giving you output. Then that is what is called distorted. The output what you get from the loudspeaker is also giving some of the high frequency components or harmonic frequency components. Therefore your voice signal is distorted. We don't want amplitude distortion. Therefore the system which is not having amplitude distortion, the system which is not having frequency distortion, the system which is not having phase distortion, that system is said to be called as high-fi system, high fidelity system. Therefore these are all high fidelity or fidelity considerations. Okay. But practically whether the system is linear or not, that is what we need to consider. That is the reason why maybe if you take signals and systems and control systems, always the system is linear only. We always analyze the techniques or apply the techniques for linear time invariant systems. Time invariant is nothing but that is aging. With respect to time the system parameters change, but practically people assume, right? The parameters are not changing, let us say time invariant system and the system is linear. That is compulsory. If system is not linear, we will get harmonic distortion and superposition principle is not valid. Okay, take it. Therefore we are understanding what is amplitude distortion and what is the reason to have amplitude distortion. The reason to have amplitude distortion is nothing but non-linearity of the system. Okay, take it. Therefore we want linear amplifier. After this I'll give you observations, then I'll explain practically if the system is non-linear how to get linearity. Okay, that part I'll explain. Take it. I'll give you 1 more minute. Okay. Write down over. Now tell me the BJT amplifier. If you take BJT amplifier, okay, and what is BJT amplifier? Let us say common emitter amplifier. This is RC and VCC, and this is your VI, right? And now this is your V0. We are applying the signal. Let us say the signal whatever you want to amplify. This is the signal, right? Then let's see the relation between VI to V0. We want linearity. I am speaking about linearity. Therefore, we will not see any amplitude distortion. Then tell me if I take this is collector, emitter, base, and this is nothing but NPN transistor. This is NPN. This is nothing but a PN junction diode between base to emitter, right? Then whatever input voltage you are applying, right, that is what you are trying to pass. This is nothing but your IV. This is nothing but your IB, okay? This is IB, and whatever current you get here, this is IC, right? Now we want to know, tell me if you take DC equation, what is the relation? IC is equal to beta into IB plus 1 plus beta into ICBO. This is what is equation 1, which is what is giving the relation between IC to IB. But what is the second equation? DC equation. What is the relation between VBE to IB or VBE to IE? That is nothing but what voltage across PN junction diode is input voltage. Current through PN junction diode is nothing but your input current. We know that, right? Therefore, you can say IB is equal to some constant into e to the power of VBE divided by VT minus 1. That is what it is, right? Which is part of. But here what is I0? That is what is different. What it may be. This is what is proportional to it, right? Therefore, now tell me what is the relation between IB to VBE? Non-linear. I is equal to e to the power of x. 1 plus x square by 2 factorial plus x cube by 3 factorial plus x to the power of 4 by 4 factorial plus etc. Therefore, this is completely non-linear. Therefore, the relationship between IB to VBE is non-linear. Therefore, if you give VBE, right, you will get non-linear IB, non-linear IE or IB. When you get non-linear IB, then what is the relation between IB to IC? I can say this is kind of linear. Therefore, IB to IC is linear. Then again IC to output voltage linear. Therefore, whatever output current you are getting, that you are trying to pass through RC, then you are getting linear relationship. Therefore, output current to output voltage linear. Output current to input current linear. Output current to input current linear. But input voltage to input current, that is nothing but VI relationship of a PN junction diode, non-linear. Therefore, if this is what is the case, This is what is the case. The relationship between V0 to Vi non-linear. Therefore, this is what is non-linear. Non-linear amplifier. This is what is non-linear amplifier. Your BJT is non-linear amplifier. Not only BJT, your MOSFET is also non-linear amplifier. Right? Then what to do? We are saying that till now when you apply small signal, when you apply the input signal, when input is increasing, IB is increasing, IC is increasing, drop across RC is increasing, output voltage is decreasing, the relationship between input output is non-linear inversion. We are saying always when you output peak to peak divided by input peak is nothing but voltage gain. We were saying till now, and then we solved all AC parameters assuming that the relationship between input output is linear. But fundamentally the relationship between input voltage to input current is non-linear. Then what to do? Right? Therefore, your BJT amplifier is non-linear. Then, how to get linearity? The next point is how to get linearity, right? The non-linear system or non-linear amplifier can be converted into linear amplifier. By small signal input. That's why we are calling this analysis, whether it is BJT or MOSFET, we are saying small signal analysis or by applying small signal input. I can explain. If you take non-linear, this is Vi and then this is V0, we know the relationship it is non-linear, right? Then if you take non-linear, that we know all the distortion. But don't apply completely the input, just you apply the input here, then can I say this is what is linear? Therefore, if you zoom this portion, this is completely linear. Therefore, when you apply your input signal, then whatever output you get, right? Whatever output you get, right? Then when input is changing here, then your output also, this is what your operating point, your output also changes linearly. Therefore, this is what is giving you linear relationship. Therefore, by applying small signal, this is what is our small signal. Even though system is non-linear, we can get linearity. Even though system is non-linear, by applying small signal, if you apply large signal, you will get non-linear, amplitude distortion. But when you apply small signal, this is nothing but everywhere if you see smaller portions, that is nothing but linear, then we are getting linearity. Therefore, non-linear amplifier will become linear amplifier by applying small signal. That is what is very important. Okay, take it. I think the session is over. We have only 1 minute time. If you are able to complete this in 1 minute, fine. Else you can pause the video and then you can take it. The solution to get linearity from non-linear amplifier is nothing but small signal. Okay, thank you. We'll cut it in the next session.